Hello everyone, welcome to this video. In this video, let's see a very interesting question. So let's have a look at this question. It says that an abstract algebra teacher that intended to give a typist a list of 9 integers. What kind of integers he gave to them to the typist? He gave 9 integers which form a group under multiplication modulo 91. Isn't that interesting? Yes. And instead one of the 9 integers was inadvertently left out, so that the list appeared as only these 8 elements, right? So they are asking which integer was left out. So we need to determine by because we know this property that it forms a group under multiplication modulo 91, hence we can very easily calculate it. So let's see how we can do it. Now this incident actually happened. The book from which this question is taken says the same thing, right? So now let's use our knowledge of abstract algebra and solve this question, correct? So for the solution here, because we know the 9 integers, right? So as let's call the missing one as x. So 1, 9, 16, 22, 53, 74, 79 and 81 form this set forms a group under the operation of multiplication modulo 91, right? Thus it follows the very first property, closure property, correct? If it follows the closure property, then we can make use of it, and at most we need to perform 8 such calculations in order to find all the elements, because when you compose all the elements together, when you multiply all the elements together under this operation of multiplication modulo 91, we would obtain the missing number, right? And if we are lucky enough, we would get our number in fewer calculations. So let's see how we can do that. So if you multiply any number by 1, you would get back the same number, even if we are taking the operation as multiplication modulo 91, right? So let's skip multiplication with 1, right? So let's start with the next number, next smallest number, which is 9. Why I am taking smallest? Because it would reduce some of our calculations. So here let's proceed with calculating what is 9 multiplication modulo 91 with 16. So when you multiply 9 and 16 together, you would have 144, and you have to perform the calculation under mod 91. So that means when you divide 144 with 91, you would have your remainder as 53. You can check. So your answer is going to be, this is going to be 53, right? And let's call this by some name. Let's call this by S. So this clearly belongs to S, right? So let's that doesn't prove our purpose, right? It belongs to S. So let's find out another calculation which give us some element which is not present in this set. So this is our aim. So we are next multiplying 9 with 22. So 9, when it is multiplied with 22, and when you perform the calculation, so first of all let's perform this calculation. It would be 198, and we need to calculate 198 modulo 91, right? So what would it be? When you divide 198 with 91, it would go on 2, right? So what would be your remainder? Your remainder would be 16, right? So see, you have 16 as your answer, which is again present in S. So that means we have to go and look for some other combination. So let's multiply 9 with 53. So let's see what do we have. So when you multiply 9 with 53, you would have 477, and when you calculate 477 under mod 91, it would come out to be 22. Again 22 is present in S, so that means we would have to go and calculate another calculation. Let's do that for 9 with 74. Let's see what do we have here. So when you multiply 9 with 74, you have 666, and we need to calculate 666 under mod 91. So this would be equal to 29, and surprisingly enough 29 is not present in S. However, because as it is given, S forms a group, right? Hence, by the closure property, this 29 is present in the set S. Hence, we have calculated the missing member. Hence, the missing integer is calculated. So you see, once you obtain some number which is not present in S, we are done with our calculation. So we just have to perform these 4 calculations in order to reach at our solution. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.